Welcome to SO 305, Lecture 4, Data Organization and Frequency Tables. Introduction. Collection of data for solving problems leads to a large mass of data. In its original, unprocessed state, data so collected appear meaningless. They need to be condensed or understandably before they can be of much use. In this chapter, we shall look at how frequency tables via tally system, both for ungrouped or grouped data, are constructed for meaningful data presentation. Objectives. At the end of the lecture, you should be able to define frequency distribution and prepare a frequency table from a non-grouped and grouped data. Pre-test. What is a tally in statistics? 2. What is a frequency distribution? Content. Data are set of usable information collected in numerical form. The set of data could be a set of numbers, figures, or measurements derived from observation. However, the data so collected could be arranged in such a manner that a meaningful interpretation could be easily made. The first step to make a meaning out of data so collected is to arrange them into what is called frequency distribution. Listing of data. Listing of the data is writing the data out. Listing is a prerequisite of grouping for analysis, a pattern that assists in cross-checking. When a large number of observations are involved in the listing, tabulation comes in to prevent flaws that might crop up. For example, Table 1. In a statistics test for 40 students, the following marks were obtained: 2, 7, 6, 9, 3, 4, 7, 8, 5, 5, 4, 5, 3, 6, 6, 5, 4, 9, 6, 6, 6, 7, 5, 4, 8, 3, 4, 2, 8, 5, 2, 3, 4, 7, 8, 3, 3, 2, 7, 4. These scores are termed raw scores because they have not been meaningfully arranged. Frequency table. A frequency table is a tally of the number of times each score value occurs in a group of scores. Therefore, the first step to be taken in making the raw data more meaningful is to relist the figures in order of size, that is, rearrange them so that they can run from the lowest to the highest. Such a list of figures is called an array. Since some of the values occurred more than once, it will be clearer if each figure were listed once and the number of times it occurred written alongside as shown below. Table 2. A. Ungrouped data. In statistics, the number of occurrence is called the frequency and symbolized as F. And what you have in Table 2 is called an ungrouped frequency distribution table. Therefore, an ungrouped frequency distribution is a list of figures occurring in the raw data together with the frequency of each figure. The frequency for each figure is easily obtained through the use of tally, strokes. In order to prepare a frequency table, therefore, we count the number of strokes, that is tally, for each mark to obtain the frequency for the mark. For example, prepare the data in Table 1 into a tally and frequency table. The scores in Table 1 have been arranged into a frequency distribution as shown in Table 2. The data now are more meaningful. It is easy to see and attach value, occurrence, to the marks scored. Frequency distribution thus presents the scores in such a way as to facilitate ease of understanding and interpretation. B. Grouped data. When there are too many figures for the mind to easily comprehend, the information is effectively presented by tallying. In other words, you simplify the understanding of information being given by the figures of grouping them. For example, assume you use this course for another set of 40 students in statistics examination thus: 42, 47, 43, 39, 24, 34, 50, 33, 35, 46, 32, 57, 52, 54, 29, 59, 49, 50, 61, 48, 42, 61, 44, 31, 47, 32, 30, 51, 31, 46, 20, 56, 47, 27, 44, 32, 44, 46, 40, 55. To construct a frequency distribution for the above table requires 3 major steps. 1. Choose the classes into which the data are to be grouped. When grouping data, do not let the width be too large, otherwise there will be the loss of information, not too narrow. You will be back to the problem of too large numbers to manage. 2. Tallying. And 3. Counting the number in each class. In choosing the classes, the following should be done. 1. Find the range of the data, that is, the value of the largest mark minus the value of the smallest mark. For example, 61 minus 20 is equal to 41. 2. Estimate the size of the class intervals. It may be less than 10 if the total number of classes is small, and it may be more if the total is very large. For example, 5 intervals. 3. Decide the number of the class intervals. This is done by dividing the range by the number of intervals selected in 2 above. Round off the result to the nearest whole number so as to accommodate all variables. A trade-off between losing information, that is wide class interval, and presenting a meaningful visual display. Choose an interval with neither too wide nor too narrow. For example, 61 minus 20 divided by 5 equals to 41 divided by 5 is equal to 8.2 equals to 9. 4. Select the lowest class interval so that its lowest stated limit is evenly divisible by the size of the interval. For example, 20 to 24, 25 to 29, and so on. 5. Make sure that the observations belong to only one class. And 6. Make the classes of equal width so that each will cover the same range of values. Now, construction of the tally and frequency distribution for Table 3. Summary. In this lecture, we have discussed how data collected are organized into frequency distribution. The frequency distribution for both grouped and non-grouped data were examined, and the steps involved in the construction of frequency were also taught. Frequency distribution was seen as a system for classifying data, usually in a tabular form, so that the frequency of observations in each class can be ascertained. We have come to the end of study session 4. Thank you very much for listening.